the all-new Sovol M1D IDEX tool changer. You all want to see the prints? I hear you. We are one of the few to have a pre-release prototype here. Today you'll see a bunch of prints. We'll compare to our Bambu Lab, Creality and AnyCubic material changers. We have a PETG print with PLA supports for our channel exclusive MelGeek Mid 84 V2 and a staggering 6 attempts at 2 PLA figures with PETG support. Did we succeed? You'll have to watch to the end to find out. All I can tell you is we are fixing plenty of mistakes, including a terrifying moment where the tool had decided to run a homing sequence right in the middle of a print and crashed straight into the model. And the craziest part? The root cause wasn't a broken part. The printer broke because I actually managed to fix its internal cameras. I'm gerGO and welcome back to gerGO Print 3D. On this channel, my little nephew Levi and I have a blast exploring 3D printers, laser machines, and bringing you along for the ride. And just like all our previous videos, this one comes with curated, translation-ready subtitles, detailed chapter markers, and even multi-language audio tracks, so check out if your native language is available. Today we are taking an honest look at the Sovol M1D. As an early tester, my job is to find the bugs on this prototype so that the production units shipping to backers are as flawless as possible. Talking with other testers who are using closer to release variants, I know things could and will change. You just have to keep that in mind. With the Kickstarter wrapping up in just a few weeks, it's time to show you the truth. Tool crashes, nozzle cam firmware flashing, and a hidden slicer trap that completely ruined the print. But after sorting everything out, the print quality, speed, efficiency, and reliability of the M1D is really exciting. I know you want to see them with your own eyes, so let's get right into it. To establish a baseline, I reprinted a couple of familiar models. First, this chubby little penguin Levi liked so much. To make it a fair test against our Bambu H2S, I printed it on the M1D out of the same filamentary white and yellow, adding PLA Blaster Black this time. If you live in the EU, you should definitely give filamentary a try. It's verifiably high quality, at very good prices, reduced even further if you use our discount code. Besides the minimal filament upgrade, more importantly, I printed the M1D copy in the exact same orientation as on the H2S, minimizing color changes, though they wouldn't be half as wasteful here. I changed a few slicer settings too, but these shouldn't affect surface quality. On the H2S, we went for strength and used 4 walls and gyroid infill, as it was published on MakerWord. On the M1D, I cheaped out with lightning infill and just 2 walls. Our H2S print had an ugly back because of old degraded filament we used for the black. Here, the back fused to the supports and tore as I removed the model from the build plate because of that weakened back. But if you look at the front, you can judge the print quality for yourself. We printed 2 on the H2S, 1 for each of us, so we have to trust slicer estimates, but I found both our Bambu and this new M1D give very accurate time and material use estimates now. In direct comparison, the M1D was 3 times quicker, wasting 5 times less material, only purging for the prime tower and supports. Next up, the articulating turtle. This was a direct comparison against the AnyCubic Cobra 3 and the Creality K2+. Look at this. With traditional CFS and ACE systems, we got a mountain of plastic poop. On the M1D, 0 purge waste, none. Just this tiny prime tower to equalize nozzle pressure. The surface quality is fantastic, sitting comfortably right between the K2+ and the Cobra 3. The Cobra 3 taking the crown so far. For this, we used Filamentary's PLA Blaster Black. gerGO green and gerGO coffee brown. And speaking of gerGO, they have just sent us their CMYKW kit, which we will be featuring in an upcoming video. I guess you know what we are planning. Let others know in the comments below. Follow the link in the description to their website. By the time you view this video, they might even be selling these kits targeted specifically at tool changers. Now I promise you a word exclusive, and here it is. You might remember Levy's Night Purple Melgeek Mate 68 keyboard. Well, Melgeek has just sent us their brand new unreleased Frost White Mate 84 Ultra V2 with a bunch of extra keys. I'm told no other YouTuber has this keyboard yet, making this again a true channel exclusive. This keyboard is 3D printer customizable. To celebrate, I designed a customized light bar for it that spells out our Kickstarter affiliate link for the M1D. This is where the M1D's two IDEX tool heads absolutely shine. This massive light bar fits diagonally across the area shared by the two tool heads. I used two transparent PETG colors from Filaments, yellow and violet glass, for the bar itself, and PLA for non-sticking support. Because the M1D has independent nozzles, mixing these completely incompatible materials was effortless. Yes, we figured out the prime tower issue from last time. More on this a bit later. Some people complain about Sovol's decision to make the M1D an IDEX tool changer, but this right here proves why it's brilliant. Thanks to those dual heads, the M1D printed this entire model with just a single physical tool change. By having the yellow loaded in the fixed left IDEX head and the PLA support material loaded into the right tool changer carriage, the printer alternates seamlessly between the two heads for the first half of the job. Then simply drops the PLA, picks up the purple PETG and finishes the print alternating between the two PETG colors. The PLA supports snapped right off the PETG like magic. This print took under 3 hours, which is way faster than our old H2S or any of the other material changers could have managed with all those mechanical material swaps, not to mention these superior supports. I even printed a custom cover for the Mate 84, but that is a teaser for a dedicated video coming very soon. In the meantime, if you want to check out the Mate 68 V2 or the new Mate 84 V2, our affiliate links are in the description below. Before we could tackle our next massive print, we had to do some tuning. Great news first, Sovol released a major firmware update that finally addresses printer-to-slicer filament synchronization, a feature we sorely missed in our initial testing. But I was still having trouble with the automated dual x-axis stepper calibration. The printer uses two tiny down-facing cameras behind the nozzles to read crosshairs or chess marks, as they call it, on the back of the bed and perfectly tune rotation distances for the independent tool heads. But it kept erroring out. Well, remember how this is an early evaluation unit. You've seen it in the last video, the tiny protective shipping peels were still on the internal camera lenses. But just removing those did not completely fix them. Turns out, during the first 2 weeks of tests, these cameras were still working even with those peels on. I pulled the photos they had taken from the openly accessible internal memory of the printer, and you can tell the early pictures were a bit hazy. But a firmware update in late July broke the communication with these Bluetooth cameras. Now I understand why. Their clipper routines were updated to need 6 images from each camera instead of just 3. The Sovol team instructed me how to detach the camera units from the tool heads, hook them up to a USB TTL serial tool on my computer, and flash new custom firmware to the ESP32 Bluetooth modules inside. Now do not panic. I want to assure any backers watching, you will not have to do this on the production units. But for the maker community out there, I promise I will make a dedicated DIY video on how to flash these ESP32 chips, because there is a huge lack of good tutorials online and it wasn't trivial. And if this isn't a good point in the video to ask for a like and subscribe, I don't know what is. Levi keeps telling me to ask for hypes too. A few weeks ago I didn't even know they were a thing. These are the times when I feel like the boomer I am. With the firmware flashed, the automated calibration ran beautifully, giving us a rock-solid foundation. Well, mostly solid. You'll see what I mean later, but boy did we need those working cameras for what came next. Enter Spider-Man, a gorgeous model requiring 700 color changes. Nobody in their right mind would print something like this on a single tool machine. We loaded up our M1D with tag bears blue and red, Filament 3 white and black, and Sovol black PETG for the support interfaces. Now one more tease for that follow-up video. Tag Bear is also sending us CMYKW colors, but they are opted to send PETG, and they are even throwing in a transparent PETG. We'll be sure to show you the spools as soon as they are delivered. Look around on their website by following our links in the description. Thanks to your feedback on our last video where we fought with these PETG supports, I found the fix for the Prime Tower. Just enable the option, Tower interface features, and the slicer will make sure no layer consists of a single filament type, thus preventing layer separation. So was it an instant win? Let me remind you, you are watching gerGO Print 3D, and we make and solve mistakes. Everything was going beautifully until we reached the white eyes in the last 20% of the print. The white PLA that was loaded in T1. When I went to check on the print, it was halted with an E3 toggle blocked error. I hit resume, but noticed the printer struggled to drop the T1 tool head carrying the white PLA. I watched it a bit longer, until a few tool changes later it again had to retry dropping T1 a few times. Then, even though it failed to drop T1, it still attempted to pick up T2, violently smashing the two tools into each other. Scary. The whole affair happened 2 more times during the 60 or so changes involving T1 in this print. I was able to recover each time, but they eventually caused a massive layer shift, and T1 even stopped extruding, so the print was mostly ruined. I was frustrated, but I noticed this was only happening to T1. The optical presence sensor got some dust or debris stuck into it. We are coming back to this in a few minutes, but with 7 tools on this printer, and this print only needing 5, the M1D offers a lot of redundancy. Before figuring out what was wrong with T1, I went ahead and reprinted the model using a different tool for the white. I wish I could tell you this second attempt was flawless, but sticking to the truth, a support fell over, most likely due to me smearing oil on the build plate with all the commotion of the last fail. For the third attempt, however, I washed the bed with soap, wiped it with IPA, and even sprayed it with this magic glue spray I've linked in the description. No tool crash, no adhesion issue, just pure perfect print. Just look at the instantaneous tool changes going from red in the IDEX head to the blue in the toolchanger. And the colors align as if they were printed with a single head. The XYZ alignment of the tools is perfect in my printer. The up-facing alignment camera and the clicky button do their job perfectly. I'm actually planning to give you a deep dive into the calibration process. It's so interesting in a future video. You could hear me laugh out loud as I wiped off those black PETG support interface pieces from the butt of the model so effortlessly. Should we print a diaper for Spider-Man next? Just look at the end result. Print surface quality is on par with our Bambu and AnyCubic. This small blemish along the arm and the imperfections in the color paint are both part of the original model we got from MakerWorld. Based on the abilities of my unit, you should not worry about the print quality of the M1D. But obviously I couldn't let that T1 crash go. I needed to know if the slot was permanently broken or if my dust theory was correct. After inspecting and cleaning the optical sensor, I sliced this cute knitted German Shepherd model using gerGO coffee brown and filamentary black. I chose this model specifically because it requires swapping between these two colors on every single layer. It was originally intended for the Bambu Lab H2D, which too can deploy two extruders simultaneously. But this time, I forced our M1D to use the T1 and T2 slots for every single layer. According to the slicer, this requires exactly 416 tool changes. I hit print and it started okay, but 120 tool changes into the printer went totally berserk. T1 didn't just fail to drop a tool, this time it failed to pick up the tool entirely. It kept retrying multiple times. I resumed the print and it kept looping without success. Then, instead of pausing, it did something terrifying. It went into a homing sequence right in the middle of the print. T0 crashed straight into the model and I had to kill the power. Now remember, this is pre-release software. We are experimenting with different versions. I manually lowered the bed, removed the ruined print and homed the printer. I tested T1 through the UI and it failed with an E1 grab T1 failed error. It was completely misaligned with the tool. My dust theory was dead. Then I had a revelation. It wasn't debris. It wasn't the new firmware. It was all me enabling those cameras. Looking through the historical system files from before the debilitating firmware update, I saw the cameras gave a stepper rotation distance of around 38.97. Then, as the update broke them, the printer fell back to a default value of exactly 39.0, a difference of just 0.03, and everything was printing fine. But when I flashed the cameras and ran the dual x-axis stepper calibration without the peels, using the new routines, the printer generated new, highly precise measurements of about 39.13. The problem? The little crosshair stickers on the back of my early prototype bed are probably slightly off compared to production models. That tiny 0.13 difference in rotation distance multiplied across the x-axis caused about 1.5 mm deviation, 300 mm from the tool changer's X limit switch on the right, from where the T1 tool sits. Due to the new calibrated values, the tool head was physically missing the grab point. For context, my testing colleague 3D Print Demon's original test unit got lost in shipping, so Sovol sent him a much newer revision that is closer to production, and his automated calibration works perfectly with the crosshairs printed on the back of his print bed. So the fix for my prototype? I went into the config and manually restored the default 39.0 values. I ran the 416 tool chain challenge again, and it grabbed and dropped T1 flawlessly. Over 400 changes, 0 crashes. But there was a final plot twist. The tool changer worked, but the print failed anyway. A support fell over once again, and this time the whole print even came loose from the PI sheet. I was baffled. Soap, IPA, and even that spray glue. How could it fail? Then I realized the hidden trap inside the slicer logic, the final piece of the PETG support puzzle. When using PETG in the print, even if the support interface doesn't even touch the build plate, this Orca slicer fork automatically heats the bed to 70 degrees. The PLA base was sitting on a 70 degrees bed, which is past its glass transition temperature, causing it to warp and lose adhesion. The ultimate fix? I went into the filament settings for the PETG support material and forced the bed temperature down to 50 degrees to match the PLA, and I widened the support brims just to be safe. I hit print one last time, and this time it was absolute perfection. Flawless tool changes, zero warping, and the PETG interfaces peeled off like a dream. So what is the truth about the Sovol M1D prototype? Yes, there were beta hiccups. The camera peels, the firmware flashing, the calibration offset on an early unit, and the learning curve with mixed materials in the slicer. But the baseline mechanical precision of this machine is incredible. The technology is unbeatable. The zero waste, the speed of the true IDEX, and the sheer redundancy of having 7 tools allowed us to bypass a hardware failure mid-project. For a production environment or a serious maker, this machine is shaping up to be an absolute powerhouse. And if you're thinking about backing this project, the Kickstarter is ending soon. Please use our custom link gp3d.click/m1d. It's written right here on the back of my beautiful Magic keyboard. Using that link supports our channel at no extra cost to you, and we truly appreciate it. I've also dropped discount codes for our amazing filament sponsors, Filamentry, gerGO, and TechBears in the description, alongside links for the Magic keyboards. If you enjoyed seeing us troubleshoot these issues, you will love our recent video on slicer tricks, where we printed the first 2 chubby penguins, and don't miss our last M1D video pretending to be a laser review. Now go print 3D. Thank you for watching another gerGO Print 3D video all the way through. Go Sovol!